right, here's your second chance with this version of a basics quiz. Find the center and radius of the circle if x squared blah blah is equal to negative 17. So we're going to do the complete the square technique. I'm going to take half of 10 and I'm going to get negative 5, and I'm going to square that negative 5 and I'm going to get 25, which I add to both sides. Moving forward to the y component, I'm going to do the same thing. I'm going to take half the b term, half of 8 is 4. I'm going to square that 4 and get 16, and I'm going to add it to both sides. So I had a negative 17 on the left, I added 25, and I added 16. Now I'm going to do my favorite F word, which is factoring. This factors is x minus 5 times x minus 5. This factors is y plus 4 times y plus 4. And if I put these numbers together, I don't even know what I have. I'm so tired. I have 24. That seems right. I feel like it's right. 24. If something's written twice, it is squared because it is multiplied by itself. Now, the center is going to be at 5, negative 4, because we change sign, we leave parentheses. I know that the radius squared is 24, so r is the root of 24, which is the root of 4 times the root of 6, which is 2 roots of 6. Ta-da! All right, what is the domain of G composed of f of x if f of x and g of x are whatever they are respectively? Now, this is this version of the notation, which means I'm going to take everything in f and I'm going to put it into g. So this is going right there. I'm going to have the root of 3 times 3x plus 5. Don't forget this minus 4. It's going to give me the root of 9x plus 15 minus 4, which is the root of 9x plus 11, which one of you will probably try to do something with. You don't have to. Now, I don't even care what this is, to be honest with you. I care about the domain. For the square root of anything, the stuff inside is greater than or equal to 0. So 9x plus 11 is greater than or equal to 0. 9x is greater than or equal to negative 11. X is greater than or equal to negative 11 ninths. Easy peasy lemon squeezy. Number 3 is a factoring problem. It takes an x squared and an x squared to create x to the 4th. Factors of 24 are probably going to be 6 and 4. Notice I have to add to a negative 2, so minus 6 plus 4. Now, I want all the zeros. I set that bad boy equal to 0. X squared minus 6 is a 0. X squared is 6. X is plus or minus root 6. This guy, x squared plus 4 is a 0. X squared is negative 4. X is plus or minus the square root of a negative 4, which is plus or minus twice I. And again, I'm saying it's I because you know full well the root of a negative 1 is I. Like, you know that. At least you're supposed to know that. But some of you go, I don't study. And it shows that you don't study. All right, cosine of 2 pi minus pi over 4. I'm sure a couple of you have no idea how to do this piece right here, because bless you. You know, however, that 2 pi is 360 degrees, and you know, however, that pi over 4 is 45. So you're actually finding the cosine of 315 degrees. Though it goes to the unit circle, and it thinks about what's there at 315 degrees. What's there is a positive root 2 over 2 and a negative root 2 over 2, and on the unit circle, cosine is x. There's my answer. It's going to be root 2 over 2. Construct and simplify the difference quotient for f of x is 2x squared minus 3x plus 5. Notice I did not give you the difference quotient. I'm going to do f of x plus h first, which means that everywhere I see an x, I'm going to let it be x plus h. And I'm going to go ahead and write that twice right now to save myself a line. There's a pattern to this answer. Like, if you'll study your answer and look at the original equation, and you have an IQ above about 90, you should be able to see the pattern. X plus h times x plus h is x squared plus 2xh plus h squared. Then minus 3x minus 15 plus that 5. Distributive property 2x squared plus 4xh plus 2h squared minus 3x. This is an h. That's an h. I looked at that thing and thought it was a 5. But it's an h. So minus 3x minus 3h. And then we have the plus the 5. All right, now, the rest of the difference quotient, and I didn't write it down, but the next thing you do is you're supposed to take away f of x. So take away 2x squared. Notice I wrapped. And it's all over h. If it exists in here, it cancels out. We are left with 4xh plus 2h squared minus 3h, all sitting pretty over an h, and all four pieces have the h. So I cancel out 4x plus 2 minus 3 plus 2h minus 3. It's an h. It should be written as 4x minus 3 plus 2 h's. That's all there is to it. 7 is find a solution set for x minus 3 over x squared minus 4. About the only thing I can tell you is true is that x minus 3 is less than 0, which tells me that x is less than 3. Okay? That's going to be a true fact. X is going to be less than 3. Now, I can find what we call critical values of x. X squared minus 4 is not 0. Therefore, x is not plus or minus 2. So I have to do kind of an old school idea with tables. I have to see what happens. So let's put negative 2 on there, and something less than negative 2 is negative 3. Let's put something between negative 2 and 2. Of course, we have 3, which we know will fail, supposedly, because, anyways, 3 is going to fail. And 4 should fail. Everything here should fail from now on. But anyways, this piece is going to be true. All right, well, this piece is going to fail. If I take a negative 3 and I plug it in, I am at negative 6 over 5, which is, in fact, less than 0. So this is true. If I take a negative 2, I'm going to get something over 0. That's what's going to happen. Hopefully you're paying attention to that, which is undefined. I knew I couldn't be that number, all right? If I plug in a 0, what happens? If I plug in a 0, I have negative 3 over 0 squared minus 4. So I have negative 3 over negative 4, which is 3/4, which is false. Interesting. I kind of thought it would work, because I get 3/4, and 3/4 is not. If I plug in a 2, what happens? Well, it fails. If I plug in a 3, I would have 0 over 5, which is false because that's 0. So nothing there, fails. And what do we have here? We plug in a 4. If we plug in a 4, we have 4 minus 3 over 4 squared minus 4, which is 1 over 12, which is also false. This is the only thing that's going to work. Crazy. I would have expected more than that. I am really surprised by that. I am. It makes me want to refer back to a calculator, or maybe I should have made a smaller table. We have x minus 3, and it's divided by x squared minus 4. I evidently have some other stuff going on here. There is a little window right here that I didn't check. It's right there. I should have checked it. I should have checked something between 2 and 3 because those are my critical values. Should have done it. Should have checked 2.5. Never did it. 2.5 minus 3 over 2.5 squared minus 4 is going to be negative 1/2 over 6.25 minus 4. So negative 1/2 over 2.25. And this is definitely going to be negative. So this would have been true. I knew there had to be something going on here. So what I've learned here is that I can be from negative infinity to negative 3. Actually, not to negative 3, to negative 2, the critical value, unioned with 2 to 3. Those are kind of tough in that you just have to go like super old school and make a boring table. Ugh, that's hideous. Who wants to do that? 8, determine the equation of a line that is perpendicular to the line that contains the points negative 5, 4, and negative 2, negative 5, and passes through the point 2, 0. Only about half of y'all got this one. Your slope is going to be y2 minus y1 over x2, which is negative 2, minus x1, which is negative 5. So negative 5 minus 4 is negative 9. Negative 2 minus negative 5 is 3, and we get negative 3. Now, we're talking about perpendicularity, so the perpendicular slope is 1/3. That question on that particular, the last one, was as simple as identifying the line with the right slope. Anyways, I'm going to pass through a point. It's 2, 0. I'm just going to do point slope form. Y minus y1 equals m times x minus x1. Y minus 0 equals 1/3 x minus a negative 2. Oh, that's not right. Too many negative symbols. 2, 0. So that's just going to be y. I'm going to have 1/3 of x minus 2/3, and that is my equation. Easy peasy. All right, moving forward to number 9, you got a trig problem. You got to factor it. It takes a twice cosine of something and another cosine of something to create a twice cosine squared of something. I should have used x's, sorry. Factors of 3 are going to be 1 and 3, and I believe that's the correct order. If I want to be negative 7, the outside would make 6 cosines, and the inside would make 1 cosine. They're both negative. And a negative 1 times a negative 3 is a positive 3. So this is the factorization. Time to use what we call the zero product property. 2 cosines of theta is going to be 1. The cosine of theta is 1/2. Think about your unit circle. This covers the entire unit circle. There are 2 places on the unit circle where the x value is 1/2, and they are right there and there respectively. That's going to be 60 and 300 degrees. That's it. Okay? Now the other one would say that the cosine of theta is 3. So what you have to ask yourself is it possible for cosine to exceed 1? It doesn't exist on the unit circle, does it? I don't think it does. And the answer to that is no. So this equation right here is what we call junk. It's literally just complete nonsense. There's nothing there. It's not extraneous. Don't try to think that you're like some educated person. You say, oh, it's extraneous because I'm intelligent. No, it's nothing. It's meaningless. It's not extraneous because extraneous is an answer. This is not an answer. That's junk. Number 10, if log base A of 2 is equal to 1.025 and log base A of 5, oh, actually, I need to stop because I've got a class coming. I got to get ready for them. So I'll do this at some point.